start recording. There we go. So if I need to do 36 to the 1/2 power, does anyone remember how to do this? Anybody remember?
Yeah, I think it'd be like a radical 36.
It would, yes, it would be a radical 36. You are basically taking your denominator and that's becoming your index, right? So we don't have to write the 2 there, but it is becoming like the grouped number, right? So what is the square root of 36? 6, yes, thank you, 6. So the same idea here, right? The same idea here for 1/3 power would be like we're taking the 3, we're moving it to make that the index. And then we have the cube root of 27. Anybody remember what the cube root of 27 is? What times what gives you 27? 3, yes, chat's blowing up, great job. Okay, so this is like the most mathy way, I think, of thinking through these. There is a second method, which I think is really cool, which I'm calling break in parts and then choose sum. For me, it's easy to think about it. So I'm thinking I want to break 36 into 2 parts, and I'm going to choose one of them. So basically what I mean is I need to think what number times what number gives me 36, because there are 2 parts. So 6 times 6 gives me 36, and I'm going to choose one of those, and that's my answer, 6. That's pretty cool, right? If I have this one here, I'm breaking 27 into 3 parts. What times what times what gives me 27? Well, it'll be 3 times 3 times 3 will give me 27, and I'm going to choose one of them, and that is my answer. So I can see I get the same answer here and here. It's not very exciting for these ones, right? Not very exciting for these ones. I think it is more exciting for these ones where it is not just 1/2, but actually 3/2. When I think about this one as a radical, right? When I think about this one as a radical, I'm going to take my 2, make it my index. I have 36, and then this whole thing is still to the power of 3, like that. So now I'm thinking, okay, 2, the square root of 36, that would be 6 to the power of 3. 6 times 6 times 6 would be 216. Another way to think about this is to say, okay, I want to break 36 into 2 parts. So I have 6 times 6, and I want to choose 3 of them. So I want a third one to be here. And 6 times 6 times 6 is 216. So you can see, do you guys see here how you can get the same answer thinking about it in 2 separate ways, right? This is like the more mathematical way, and this is conceptually why it means 216. Okay. Go ahead and try this one on your paper. 27 to the 4/3. I want you to try to write it in the radical form, like this, and then try to break it down into its parts, like this. Radical form. For my radical form, I'm going to take the 3, make it my index, cube root of 27. I want to take that to the power of 4. So cube root of 27 is 3 to the power of 4. What's 3 to the power of 4? 3 times 3 times 3 times 3. 81 for sure. 81. If I'm going to break it into its parts here, I'm breaking 27 into 3 parts. 3 times 3 times 3. And I want 4 of those parts. Right, so 3 times 3 times 3 times 3 is, again, 81. So we can get that same answer in both ways. Tell me, I'm going to launch a poll. Do you like option A, which is like the old school way that I believe that you learned already? Or do you like option B? You're going to have option C and D, but just choose A or B. Do you like option A, our old school way? Or do you like option B? We'll call it new school. Wait. All right. Looking like some people are undecided thus far, but we have a good number, the biggest percentage, the majority chose A, which is awesome. Keep doing it that way. If you like the new way B, you're one of those 9 people. That's why I taught you about the new way. If you don't know yet, that's okay. Keep trying both directions. In order to get good at practicing this, I am going to have us play Gimkit. I'm very excited. We're going to play Gimkit really fast. I am going to set this up. We're just going to play for 4 minutes. So it's going to go super duper fast. As we jump in here, let me make sure my settings are good. Continue. Cool. So you're going to gimkit.com/live. This is probably not going to make a link, but we'll try it. Gimkit.com/live, and your 911. Ooh, 911. 91157. Gimkit.com/live. Sorry, you have to type that in. 91157. Thank you, Galilee. Excellent. Go ahead and jump in there when you're ready. This is Sata E. Made it in. All right. I see you, Mia. I see you, Devin. I see you, David, Walter, Galilee, Kiara, Christine, Miriam. Christine with the heart. I like it. Kat, I see you. Axel, Araceli, Marley, Janet, Emily. Oh, Miss Yama. Marissa, Diana, Layla, Josh. Okay, I know that sometimes Gimkit can be a little buggy, so I'm going to go ahead and stop sharing. I'm going to share the Gimkit screen, but you actually don't need to see the Gimkit screen in order to play the game, right? You just need to be able to see your own screen. So we'll jump in. Miss Yama, I already got some chit chat going in the chat here. Miss Yama, have you played Gimkit before?
No, it's my first time, so I'll figure it out.
Oh, it's her first time, so y'all can maybe beat her this time. All right, I'm gonna jump in. We got 26 here. If you're still getting in, you should be able to still join as we're playing. All right, you're trying to make as much money as you can. As much money as you can. Ooh, Mia out to an early lead. Lots of upgrades happening. I like what I see. We're closing in on halfway. This is a quick match, quick match. Kiara in that lead. Gally in that number 2 spot. Mia in that number 3 spot. Ooh, Devin moving into second place. Walter moving into number 3. David Lopez taking over number 3 now. Ooh, Fatima, make a move. You have about 75 seconds left. 75 seconds. Amaris making an upgrade. David taking over that number 1 spot. Oh, there's Gowley. Just 40 seconds remaining. Thirteen seconds. Can someone take over? In third place, Kiara. David in second. Galilee in first place with $855. Dang, good job. Wow, impressive. Impressive all the way around. Miss Yama, how did it feel? Your first game of GimKit ever. We're happy to be here. How'd it go?
I was very confused. I was
Very
like, what's going
confused.
on? Trying to work the interface, but I caught up. But I realized people were just rolling. I was like, oh no.
Yes, people were really rolling. Yes, for sure. The trick to the game is to purchase the upgrades, Miss Yama. That is apparently the trick.
You can't. Oh, okay. Now I know.
Now you know. Sorry, team, for giving away your secrets. Yeah, you got to purchase the upgrades. Otherwise, you can't make enough money to win. So that is the trick. All right. Your clapping is ridiculous. I think this is so funny that y'all love to clap on this thing. All right. Anyways, we're going to jump over as soon as we hit 6,000. Go, go, go. Clap, 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 clap. We're going to switch over to our notes. Dun, dun, dun. 6,000. Woohoo. All right, you're done. Okay, we're going to jump into our, back into our notes. I want to take a look at my report here. I will also post the assignment version, like the one that you can play on your own. So if you wish to do more practice with this, some of us were looking really good. A few of us were having some more struggles. So I will send you the assignment version after class today, in case you are wanting to do some more practice. So let's jump back into our notes. Take a deep breath. If you are real hyped up in the GimKit world, your brain is on fire. Take a deep breath. We're going to jump into some exponent rules today. Exponent rules are probably the thing that we have learned the most so far this, like in your mathematical career, besides like maybe solving equations or like, I don't know. We've done exponent rules a good number of times. This is probably at least your third go around with exponent rules. So hopefully they're starting to like solidify in our brain. We're going to take it a step up a notch with our examples today. The goal being we're moving into exponential equations moving forward, exponentials and logarithms. And we need to have a really solid base of exponential rules in order to be able to do exponential equations and logarithms at the level that we want to. So we'll start with like the basic rules along the side here. As always, these are college style notes. So I'm going to move at the pace that I need to move. Unfortunately, I can't be super slow, which I would like to be. Feel free to write down what makes the most sense for you, right? So if something is already like super ingrained in your brain, maybe just make a little note rather than writing exactly what I'm saying here. I would highly recommend writing down the examples. You do have the video option. If you'd wish to watch the video, you can. The beginning of the video you can skip because we've already done that part. But I'll go ahead and open up the breakout rooms. If you want to go to them, you can. Otherwise, stick around with me. But if you'd like to watch the video, this is an appropriate jumping off place for that. Otherwise, we'll jump in here. So a to the power of m times a to the power of n, right? A to the power of m times a to the power of n. What do I do if I have the same base being multiplied? What do I do with the exponents? Does anybody remember? Anybody? I add them. Yes, I for sure add them. Yeah, I add them. So if I have the same base, I'm going to add them. So this is going to end up being a m plus n, like that. M plus n, like that. So I'm really adding whatever this is to whatever that is, as long as I have the same base here. So when I look at this example, take a moment to write it down here. I have the same base, right? I have the same base. So I can add my exponents together. Galilee, if you could pop over in a moment or when you have a free second, either way, fine. Okay, so we have our same base here. So I'm going to add these exponents together. Notice the exponents look kind of funny, right? They're not just like a single number that I'm adding together. This is like that next step, that pre-calculus step, is we have in a binomial as our exponent. So my base number is still 5, and then I'm going to add like terms. So 2x plus negative 4x would be negative 2x. And then negative 3 plus 5 would be positive 2. So this is the simplified version of that one there. There is a negative here. So there's like a next step that we'll do, but I will show you that one later. So for this example, when we have the same base being multiplied, we're just going to add those exponents together. Cool. What happens when we have the same base being divided? What do we do with the exponents? What do we do with those exponents there? Subtract, for sure, Brandon. Yes, Miriam. We're going to subtract them. Yes, Galilee. So if I'm going to write this version here, I'd have a to the power of m minus n. Be careful, it's the top one minus the bottom one, right? We don't want to do it in the opposite direction. As you can imagine with subtraction, it matters which one we are subtracting. All right, so if I'm thinking about this example here, give you a moment to write it down. I have 2 to the power of x times 2 to the power of 3x plus 4 over 2 to the power of 3x minus 1. Before I can get to the division step, right? Before I can get there, I need to actually do this step here, multiplication. I need to multiply these two. What do I need to do with these exponents in order to combine this into one base. What do I need to do with these? Yeah, I'm going to add them together because I have multiplication. I'm going to add them together. So I would have 2, and then 1x plus 3x would be 4x plus that 4 in the end. Right, so I'm adding these two together. I'm still dividing by 2 to the 2x plus 1. Since they have the same base, our rule that we're applying here, they have the same base, we are going to subtract the exponents. I do not want to write this all over again, so here's what I'm going to do. I'm going to take this and show that I am subtracting 2x plus 1 right here, right? So I'm subtracting that exponent. This is how I'm going to show my work. Is this super mathematical? No, but this is how I am showing my thinking for right now. So I have 4x minus 2x. So I'd have 2 to the power of 2x, 4 minus 2. And then I have positive 4 minus positive 1. So 4 minus 1 would be plus 3. I would say the biggest like stumbling block is not like you should distribute the negative, right? So I sort of did that in my head, 4 minus 1. But if you wanted to go ahead and write out and actually like distribute in the negative, you could do that as well. This is the simplified version of what we started with here. Give me a quick understanding of how you are feeling. Answer that poll real fast based on these 2 rules that we've done and examples that we've done so far. How are you feeling? Let me know where you're at. Take about 5 more seconds to vote here. Awesome. Right now, we're majority 4s, couple 5s, few 2s and 3s. If these are feeling less common to you, then it's okay. We might just need a little bit more support today. No problem. Cool. So our next one that we're going to think about here is called power of a power, right? This is when we have a base to the power of an exponent, and that whole thing is to the power of another number. What are we going to do with these exponents here? Multiply. Yeah, we're going to multiply them. We're going to multiply the exponents. So here we would have a m times n. You could just write mn if you wish. The way that I think about this is like if I had a squared to the power of 3, what that means is I have 3 a squareds being multiplied together. A squared times a squared times a squared, right? A squared times a squared times a squared would be a to the 6th power. A faster way of getting there is multiplying 2 times 3 to get a to the 6th, right? So this is that rule. So when I look at this problem here, I have 2 to the 3rd to the power of this times 2 to the power of 2 minus 2x, right? So because I have a power of a power, I'm going to go ahead and multiply 3 times x minus 2, which requires distribution here. So I'd have 2 to the power of 3x minus 6 times 2 to the power of 2 minus 2x. So this is showing that power of a power step there. What do I do now that I have a base times the same base? What do I do with the exponents now? Yeah, I'm going to add them together, right? So now I'm applying that original rule, the addition rule. So I have 3x plus negative 2x. That's going to give me 1x, so 2 to the power of x. And then negative 6 plus 2 would be negative 4. So this is the simplified version of this here. Right, so our new rule was the multiplication, power of a power, and then our old rule was here, the addition step to get there. All right. I know I'm moving quickly. Don't forget you have your video if you need to go back and check. All right. So I have a to the power of negative n. What does a negative exponent do? Feel free to come off mute if you want to explain it, or you can explain it in the chat. What does a negative exponent do? Get it? Good guess on square rooting. It does not square root. It does flip. It flips the fraction. Absolutely, Kayla. Thank you. Right? It flips the fraction. What I mean by that is, since this is a numerator, right? It is going to move to the denominator of a fraction. It's going to count as a. It's going to be a positive exponent now, which means you have a 1 on top like that. If you had something like x to the negative 2, y to the negative 3, right? That would mean that your y is going to move to the top to become positive, and your x would move to the bottom to become positive, right? So basically, it's just saying it's in the wrong location, right? If it's not in the numerator, or if it's in the numerator but it's negative, it needs to go to the denominator. If it's in the denominator, it needs to go to the numerator, right? So we're flipping there. So looking at this example here, we have 3 to the power of negative 2x plus 2. I want to get rid of this negative here, right? I want that I don't want a leading negative in my exponent. So what I'm going to have to do is I'm going to have to take the negative out of the entire exponent. So I have 3 to the negative 2x. How do I take a negative out of positive 2? What would be left if I divided out a negative? What would be left over? Yeah, minus 2, like this. Minus 2 like that. Christine, I don't know if you're muted or not. Perhaps. So I have the negative being distributed. Basically, I'm factoring out a negative, right? So the negative is out here. That negative could go onto the 2x, could go onto the 2 to create this here. So now that I have that negative, this is going to move to the bottom of a fraction, become 3, 2x minus 2. That negative, remember, telling me it's in the wrong location of my fraction. If I don't have anything left over, it's going to be a 1 on top. This is a strange rule to apply in this context. This is just a hypothetical. This is not very often does this happen in real life here. So we have our negative power there. All right. I think this is everyone's favorite rule usually. What does anything to the power of 0 mean? Anything to the power of 0. 1, 1, 1, 1. Yes, all my 1 friends. Power of 0 is going to be 1, right? Power of 0 is 1. The reason I'm thinking about this, if you're thinking like, okay, a to the 7 over a to the 7, right? Anything over itself is going to be equal to 1, right? But remember with our division rule, subtraction, or quotient rule, we have a 7 minus 7. Wouldn't a 7 minus 7 equal a to the 0? Right, 7 minus 7. So a to the 0 must be equal to 1 because all of these things are equal to each other. Right, so a to the 0 equals 1. So we have an example here that utilizes this rule. There's a lot of numbers there. Give you a second to write them down. All right. I want to be able to combine the two numbers in the numerator. Can I right now just add their exponents together like we have been doing? No, why not? They have a different base. Yeah, Axel, for sure. What could I turn 4 into so that it has the same base? Like the bases are not equal, but I want it to have base 2. 4 is 2 to the power of what? Yeah, David, 2 to the power of 2. So I could write 4 as 2 to the power of 2. And then I still have this exponent, 2x plus 2, like that. Right, so I can exchange 4 for 2 to the power of 2 because that's more helpful to me. That is going to, remember, power of a power, distribute. So I have 2 to the power of 4x plus 4 times, now I'm bringing this over here, 2 to the power of x minus 1 over 2 to the power of 5x plus 3. Now that my bases are the same, now I can add these together. So I would have 2 to the power of 4x plus 1x is 5x's. 4 plus negative 1 would be positive 3, like so, over 2, 5x plus 3. If we have something over itself, what is my answer? Something divided by itself is always positive 1, for sure. If you wanted to do the quotient rule, you could subtract them, right? You would have 2, 5x plus 3 minus 5x plus 3. It's going to give you 2 to the 0, right? Both 5x and 3 would cancel out, which is going to give you that positive 1. So 2 methods for getting to the same answer, which is positive 1. All right. If your brain is feeling overwhelmed, you can go ahead and just pause here, right? Pause here and like just be done with your notes for today. That's totally fine. If you are like, wait, miss, I want to know what this last one is, you're welcome to take notes on this last one. But I do want to release you. If something is gonna like not be in your brain, this is what I want to not be in your brain for right now. But this is what we were thinking about earlier today, right? So if you have a to the power of m over n, remember how you're going to take that denominator and turn it into your index. So you have n, a to the power of m, like so. Right, so we're doing the radical rule here. We're transferring it to its radical form. And then I'm going to go ahead and show you an example. I don't want you to freak out. So if you want to just like relax, not write this problem down, that is fine. If you want to watch this in the video again, you're welcome to. But we're going to go ahead and jump through this one. So I have the square root of this thing first. I'm going to deal with the inside of the square root first. So I know the square root is there. I'm going to let it chill for a second. What can I turn 9 into in order to have the same base as 3? What could I turn 9 into? 3 squared, for sure. 3 squared is what I'm turning 9 into. And I still have x minus 4. So this is now 3 distributing in 2x minus 8. Then here I have 3, 2x plus 2. I'm going to combine these because they have the same like base. So I have 3, 4x minus 6. And then I still have my radical. Remember, there's always been a radical the whole time. I just was ignoring it. Now, what power, right? What power is the square root? What power is the square root? It has an index of 2. It's the 1/2 power, right? So remember that this denominator, or this index is becoming the denominator here of my exponent. So the 2 is moving down here. So I have 2x divided by 2. So I have 3 to the power of 2x. And negative 6 divided by 2 minus 3. kind of wild, but this is where we get for this one. Okay. Thank you for your 1 additional minute of time. I really appreciate you. Miss Yama is going to continue with office hours. So if you do not have Spanish right now, you can go ahead and stay on. Your assignment here has we're practicing our exponent rules for each part. Something I want you to note, it says choose 7 here. So you're choosing 7 in that section. This one says try both. It is okay if you do not get the correct answers for both of them. And then choose 5 here. So you're working through 12 problems, and then you're trying both of these. Right? If you are checking out, thank you for your time today. Otherwise, I will see you later. See you on Thursday. Bye, friends. Bye. Adios, adios. Bye. Bye, guys. Bye, everyone.